Today we are going to discuss one of the most important theorems from Calculus 1, the chain rule. This theorem is a way of taking complex derivatives for composition of functions. Today we will learn what the chain rule is, the importance of it, and also work out some example problems. Why is the chain rule so important? The chain rule is a way to compute derivatives, and like all derivatives, it studies rates of change. After today, we will be able to take complex derivatives and apply them to everyday Calculus 1 problems. This rule is also used in all levels of analysis in calculus, which is just proof of calculus. We will begin by looking at some definitions of what the chain rule is. Our first definition tells us, let f and g be functions for all x in the domain of g, for which g is differentiable at x and f is differentiable at g of x. The derivative of the composition h of x equals f composed of g of x, which is otherwise denoted as f of g of x, can be given by h prime of x equals f composed of g prime of x, which equals f prime of g of x times g prime of x. Quick note, I like to use brackets as parentheses for g prime of x to help distinguish and break up the formula. You can use parentheses as brackets as given. Our second definition tells us if y is a function of u, denoted as y equals f of u, and u is a function of x, denoted as u equals g of x, then dy dx equals dy du times du dx. We will now look at a process to solve the most efficient way to differentiate h of x equals f of g of x. First, we need to identify f of x and g of x, or the inside and outside function. Then, we will find f prime of x and evaluate it at g of x to obtain f prime of g of x. Then we will find g prime of x. And finally, we will write h prime of x equals f prime of g of x times g prime of x. Now we will look at some examples to put this formula to good use. Find the derivative of h of x equals cosine 3x cubed plus 4x minus 7. First, we need to distinguish our f of x and g of x. We will make f of x equal to cosine of x, since it is our outside function. We will also make g of x equal to 3x cubed plus 4x minus 7, since it is our inside function. We will then find f prime of x, which is f prime of x equals negative sine of x, since that's the derivative of cosine. That means f prime of g of x equals negative sine of 3x cubed plus 4x minus 7. We now will find g prime of x using the power rule, and get g prime of x equals 9x squared plus 4. Now we'll write it in our final form and get the final answer of h prime of x equals negative sine of 3x cubed plus 4x minus 7 times 9x squared plus 4. Moving on to another example problem. Find dy dx where y equals 4u to the fifth and u equals 3x minus 18. Here's a quick remark that this is of the form from our second definition today, which was dy dx equals dy du times du dx. So to start, we will find dy du and du dx. By power rule, we know that dy du equals 20u to the fourth and du dx equals 3. Now we will multiply dy du times du dx. This gives us a result of dy dx equals 20u to the fourth times 3. Now we will replace u with our final function of x, therefore getting a final answer of 60 times 3x minus 18 quantity to the fourth. Moving on to our final example of the day, we will find the derivative of h of x equals e to the tangent of 4x squared. If you want to give this a try on your own first, pause the video and work it on your own, then come back. Quick remark that this is of the type of our first definition today that said h prime of x equals f prime of g of x times g prime of x. Just like our first problem, we need to find f of x and g of x, which are f of x equals e to the x and g of x equals tangent of 4x squared. Next, we will find f prime of x and evaluate it at g of x. We know that the derivative of e to the x is just e to the x, so f prime of g of x equals e to the tangent of 4x squared. Now to find g prime of x, but this derivative also needs a chain rule. So we're going to let g of x equal m of k of x, then m of x will equal tangent x, and k of x will equal 4x squared. This is an example of a double chain. You might see this come up in Calculus 1 problems, so I wanted to give you an insight here. So that means we just follow the exact same rules as before, and we find the derivative of these functions. We know that the derivative of tangent is secant squared, so then secant squared evaluated at k of x is m prime of k of x, which is equal to secant squared of 4x squared, and k prime of x would then equal 8x. That means our g prime of x equals secant squared of 4x squared times 8x. Now we can finally write it in our final form. So putting everything together, we get an answer of h prime of x equals e to the tangent of 4x squared times secant squared of 4x squared times 8x. As you can see, this is an example of using the double chain rule in a function that looked super complicated at first, but after we broke it down, it did not seem that complicated to take the derivative of. Wrapping up what we talked about today, remember these 4 steps will be the most efficient way to differentiate h of x equals f of g of x. First, identify f of x and g of x, or the inside and outside function again. Find f prime of x and evaluate it at g of x to obtain f prime of g of x. Find g prime of x, and then write it in our final form of h prime of x equals f prime of g of x times g prime of x. This topic has future importance in many math classes that you will take from here on out. Differentiation will be used in every math class that you take that has a calculus basis to it. After this class, you'll be able to use antiderivatives with u substitutions at the end of Calc 1 and beginning of Calc 2. And this also helps solve complex derivatives for the remainder of Calculus 1 and so forth. Here are a couple resources that may help with the chain rule. The first link is the textbook link that gives more example problems. The other links give explanations and examples on how to use and apply the chain rule. Thank you.